Hello students, in this video I am going to discuss the analysis of determinate trusses. We know that truss is an assembly of various straight members which are connected at their ends by means of pins. Even though the joints are either welded, riveted or bolted, still we consider the connections as pin connections. There are certain assumptions which are made in case of these trusses, that is determinate trusses. The assumptions are like this. First, the self weight of all the members is considered negligible. Second, all the members of a truss have an uniform cross sectional area. Third, all the forces are applied at the joints only, and all the joints are pin joints. Now, there are 2D, that is two dimensional trusses, as well as three dimensional trusses. Now here in this video I am going to deal with 2D trusses, that is plane trusses. Now plane trusses can be classified into three types depending upon the number of members which are provided in that truss. If the given truss follows this relation m is equal to 2j minus 3, then such truss is called as perfect truss. If m is greater than 2j minus 3, it is called as indeterminate or redundant or oversteep truss. Whereas if m is less than 2j minus 3, such truss is not used and such truss is unstable and it is called as deficient truss. So there are three types of 2D trusses: perfect truss, imperfect or oversteep, or which is also called as redundant truss, and the third one is the deficient truss. Now here I am going to discuss the analysis of statically determinate truss, that is perfect truss, and for such truss ds is 0. For oversteep or redundant truss ds is greater than 0, and for unstable, that is deficient truss, ds is less than 0. So let us go through the analysis of the statically determinate truss. Now such trusses can be analyzed by any one of these methods. The first method is method of joints, second is method of sections, third method is graphical method, and fourth method is bar chain method. Now usually first two methods are very commonly used, that is method of sections and method of joints. So in this video let us deal with the method of joints. In the next video I will be discussing the method of sections. Now here I have considered one truss in which there are these 5 number of members. Now is it a perfect truss? That we can check. We will have to calculate the number of members. Number of members is 5. Then we will have to calculate the number of joints. Number of joints is 4 over here. So 4 into 2, that is 2j, is equal to 8. 8 minus 3 is 5. So 2j minus 3 is 5. M is also equal to 5. So M is equal to 2j minus 3 means it is a perfect truss. So such truss can be analyzed with the help of equations of equilibrium. Now I am going for that. In the very first step, you will have to get the reactions at the supports. So I am getting the reactions. Now we can see that here it is a hinge type of support. So there are two components of reactions. One is the vertical component, another is the horizontal component. So VA and HA are the two components of reaction. Then here, as it is a roller support, and we know that roller support provides a reaction in a direction perpendicular to the plane on which rollers are resting. As such, the reaction at the right support, it will be acting vertically upwards. Then I will go with the three equations of equilibrium. Summation Fy is equal to 0 will give us Va plus Rb is equal to 100, which is the downward load. This is the first equation. Then if I use summation of moment about A, means I want to take moments about A. Moments about A will give us 100 into 2 minus Rb into 4 is equal to 0. And if I solve it, Rb is equal to 50 kilonewton, and as such Va will also be equal to 50 kilonewton. Now the third equation, summation Fx is equal to 0 will give us that HA is equal to 0. So there is no horizontal component of reaction at the hinge support A. After getting the reactions, the next step is to use the method of joints. Now method of joints, in this method we use the fact that as the entire truss is in equilibrium, each and every joint considered separately should also follow the stage of equilibrium, means the equilibrium conditions can be applied to the forces which are acting on the free body diagram of that joint. So again, means here as per this method we will have to draw the FBD of each and every joint. But again, while selecting the joint, you will have to ensure that at that joint only two number of forces are the unknown forces. If the number of forces, that is unknown forces, more than 2, then it becomes difficult, because we have got only two equations which can be used for the joint. Summation fx is equal to 0 and summation fy is equal to 0. So to start with, I am starting with the joint B. Let us consider joint B. At joint B, you can see that the reaction RB is acting and there are these two members. So I have shown those two members over there. Now, so if I check the forces, there are three forces at joint B. One is RB, and which is a known force. We already have obtained its value, which is 50 kilonewton. Now, it means that the forces in these two members are not known to us. Now, again, I am just telling you or repeating the salient feature of the truss, that each and every member of a truss carries an axial force only. And axial force can be of either of the tensile in nature or it may be compressive in nature. So each and every member carries either tension or compression, that is the axial force. It is the speciality of such trusses, and it happens because all the forces are applied at the joints only and all the members are straight. So here there are two members, you will have to assume certain direction. So I am assuming the direction of the force. Say this is the direction of the force in member BC. So it is FBC. Whereas I am going to assume the force in member BD, it will be say like this. It is the force in BD. Now you can assume the direction of force in the members as per your choice. You can assume any direction and you will have to apply the conditions of equilibrium. If any force works out to be negative, it means that your assumed direction is wrong and you will have to make it correct. So here FBC I have shown it acting towards the point B, and FBD I have shown it acting away from that point B, and the angle in between these two. Now as if we refer the geometry of this figure, 2 meter is the length of BD, 2 meter is the length of CD. It simply means that this angle is 45 degrees. And so the angle between these two is 45 degrees. Now if I go with summation fx is equal to 0, I will be getting minus FBD plus FBC is equal to 0, and therefore FBC it will be cos of 45 is equal to 0, and therefore FBD is equal to FBC cos of 45. Let it be equation number 1. And if I use summation Fy is equal to 0, it will be minus FBC sin of 45 plus 50 is equal to 0, and therefore FBC is equal to 50 divided by sin of 45, and we know that sin of 45 is 1 upon root 2. So if I substitute it over here, the final value will become 50 root 2. 50 root 2 kilonewtons is the force in BC, and if I substitute it over here, FBD will be equal to FBC cos of 45. FBC is 50 root 2. Cos of 45 is again 1 upon root 2. So FBD will be 50 kilonewton. So these two forces are known to us. So I am getting FBC as 50 root 2. I am getting FBD as 50 kilonewton. I am getting both the values as positive. It simply means that the assumed direction of these forces is correct, and I am showing these directions over here. So this is the force in BC. Now as at this end it is acting towards B, at the other end it will be acting towards C, and this is FBC, and FBC is 50 root 2. Now FBD is also known, it is 50 kilonewton. I am getting it as positive. It means that this assumed direction is correct, and I will be showing this direction over here, and this is 50 kilonewton. So forces in the two members are known to us. Now I will have to choose the next joint. I will have to consider FBD of the next joint. So either I can go with C or D or A. But at C, there are complications. There are number of forces. So I will choose comparatively the joint at which lesser calculations are there, and that joint is D. So I will go with the joint D. So it is the joint D now, and at joint D I know one force, that is 50 kilonewton. So I will have to show this force over there. 50 kilonewton should be shown over there. Now two members are there at which or in which the forces are not known. These forces are unknown forces. So I am showing the directions. Now I will be using my common sense. As 50 kilonewton in BD is acting towards right, 50 kilo or force in the other member, that is DA, which is horizontal member, it must be acting towards left, and this is the force in AD. Whereas the force in CD is not known. I will be assuming it say like this, FCD. But again, if I go with summation Fy is equal to 0, I can see that FCD is equal to 0. So FCD is equal to 0, and when I use summation Fx is equal to 0, FAD I will be getting it as 50 kilonewton, and I am getting the value as positive. It means that my assumed direction is correct for FAD. So FAD will be acting like this, and this is 50 kilonewton. There is no force in this member, so it is a zero force member. Whereas now if I refer the figure, I can see that the figure is symmetric. The load is also acting symmetrically. So the force in member BC and force in member AC is going to be same. So this force will be same as that of force in BC. So FAC is equal to 50 root 2 again. So this is how you can analyze the truss. But after getting the forces in all the members, you will have to prepare a table like this. Force in the first column gives us the member, or I have written over here as member, force and nature. Now member is AC, CD, CB, BD, AD and CD. There are 5 members. I am writing the forces also. Force in AC is 50 root 2. Then force in CB, it is 50 root 2. Force in BD, it is 50 kilonewton. Force in AD is again 50 kilonewton, and force in CD is 0. And then we will have to write the nature of the force, that is whether the force is tensile or compressive. Now for that you will have to remember this. Now suppose this is a member, and if it is subjected to a tensile force like this, so you know that it is a tension. If it is a tensile force, the member resists this action. So this arrow is resisted by means of such arrow, whereas this arrow will be resisted like this. So arrowheads marked towards one another indicate the tension. Arrowheads marked towards one another indicate the tension, whereas if the same member is in compression, the internal action or internal reaction will be like this. The arrowheads marked away from one another will indicate compression. So let us see for member AC. The arrowheads are marked away from one another, so it is compression. For CB again, arrowheads are marked away from one another, it is compression. For BD, arrowheads are marked towards one another, it is tension. For AD again, it is the arrowheads marked towards one another, it is tension. And CD do not carry any force, so I will be providing a dash over here. This is how the determinate truss can be analyzed using the method of joints.